Good morning, Year 10s. Welcome to the video on recapping index laws. Now, you'll have seen these in Year 9, so we're going to go through them extremely quickly, and then we'll look at many examples that you can copy down. Now, on the screen in front of you are basically a summary of the index laws. And you don't have to know them by number. For example, you don't have to remember number 3 is the one that does a power to another power, but you do have to know how to use them all. So let me explain them briefly. Here, Law 1, if you're multiplying two terms with the same base, and note that has to be the same base, then you add the powers. And if you remember why, say if you have 2 to the power of 3 times 2 to the power of 2, what that actually looks like is 2 times 2 times 2, that's 2 to the power of 3, multiplied by 2 times 2, that's 2 to the power of 2, so then we have 5 2's together, is 2 to the power of 5. Right? And you'll have seen these explanations before, so I'm not going to go through them with every single one, but essentially if you divide the powers, or divide with the same base, which sometimes looks like that, or quite often looks like that, you subtract the powers. Power raised to another power, you multiply the powers. If you have a power outside a bracketed term, then that power applies to everything inside the bracketed terms. Same with division. One rule that you may not have seen before, an unofficial 6th law, is if you have a negative power above a fraction, you can flip the fraction, note how the a and b flip, and it turns it into a positive power on the assumption that a and b are not equal to 0. Alright, now you'll need to do a fair amount of this without your calculator. So let's just look at the 3 powers for now. Looking at the 3 powers, anything to the power of 0 is 1. That's how we get there. Then, as we go either way, we basically multiply or divide by 3. Going this way, we multiply by 3. 3 to the power of 1 is 3. Then we times by 3 again. Times 3. 3 times 3 is 9. Times 3, 27, etc. Going the other way, we divide by 3. 1 divided by 3 is a third. And note that a third is the same as 3 to the minus 1. 3 to the minus 2 looks like 1 on 3 to the 2, or a ninth, because we've gone between there and there, we've divided by 3 again. So essentially your starting point for any sets of powers is whatever it is, the power of 0 is 1. Then I'm essentially welcoming back to times tables, because what I expect you to do is to start recognizing numbers that are associated with special powers. So I would expect you to recognize the numbers 3, 9, and 27 as powers of 3. And therefore, 1 on 3, 1 on 9, 1 on 27 are all also powers of 3. Alright, now, similarly, I would expect you to know and recognize all of those. If not know them by heart, at least recognize what they might be, and therefore, how to work them out. So, 2 to the 0 is 1, 2, 4, 8, 16, 32, 64. So if you see the number of 64, and you can't remember whether it's 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, it doesn't particularly matter, because what you should be able to do is know it's 2 to the power of something, let's go back and look in here. Same going the other way. 1 on 2, 1 on 8, 1 on... Ooh, I missed 2 to the minus 2 in there. 1 on 4, 1 on 8, 1 on 16, etc. And you should be able to recognize all of those 2's. You should be able to recognize 3's from power of, say, minus 3 to plus 4. 5's up to the power of 4. So 5 to the 1 is 5, 25, 125, 625. All of those are important things just to recognize and know. Alright, let's get into some examples. Oh, and 10's, you should be able to work out all of them. So 10 to the 1 is 10, 100 is 10 to the 2, 1,000 is 10 to the 3, 10,000, etc. So if you see a high power with zeros, you should know what it is, a power of 10. Alright, so same base, add the power, x to the 9. Same base, subtract the power, 3 to the 2. Power to another power, multiply, x to the 20. Hanging down, this 3 applies to everything. Note, a common mistake would be to write 2x to the 3 over y to the 3. It's a mistake because people forget to put the 3 into the 2 as well. So that's really 8x to the 3 on y to the 3. Here, the 3 applies to everything. Boom, boom, boom. Minus 3 to the 3 is minus 27. Then you multiply the powers, so we have m6, n6. Note that I've put this in brackets, and that's important, because if this was to the power of 4, minus 3 to the power of 4 is positive 81, because you have a minus, a minus, a minus, a minus. 4 minuses make a positive. If you write this in your calculator, minus 3 to the power of 4, your calculator will give you negative 81, because what your calculator is doing is it's saying, well, then 3 is the power of 4, and then there's a negative. So it will spit out that. So it's very important that you put the brackets around there. Alright, heading down, more complex ones. And these are more likely the ones you'll get in the test that take a little more work, but providing you're careful, they're fine. Alright, so let's take this one here. The 2 goes into everything. 2 to the 2 is 4, but I'm just going to leave it at, okay, yeah, 2 to the 2, m to the 6 over. Then anything to the power of 0 is 1, so that whole thing there is 1. 3 times 1 is 3, multiplied by 6 squared, n to the 5 times 2 over. Now, minus 2 to the power of 3 is negative 8, n to the 3 times m to the 4. Alright, now we're multiplying fractions. We saw this in algebraic fractions. You multiply the tops together and the bottoms together. So, what we have here, excuse me, is, well, 4 times 36. I might just write that as 4 times 36, and hopefully we can simplify that, times m to the 6, n to the 10. And then the bottom together. Bottom together is a 3 times negative 8, n to the 3, m to the 4. Alright, now we think about how to cancel things down. And looking for common factors. So for example here, I can take a 4 out and replace it with a 1, and I'm taking a 4 out of there and replacing it with minus 2. I'm then going to look at the m's. I've got 6 m's on top and 4 on the bottom. I'm going to cancel 4 out there and take 4 out there, leaving it with 2. I have 10 n's on the top and 3 on the bottom. I'm going to cancel 3 out there and 3 out here. If I cancel these out, they're just left with 1's. So what we're left with is, on the bottom, 3 times minus 2, minus 6. On the top, there's still that 36. There is an m to the 2. There is an n to the 7. Then 36 divided by minus 6, well, that's negative 6. Essentially what we're doing is we're taking a 6 out of there, so neg 6 out of there, and neg 6 out of that, which leaves 1, which leaves the 1 on the bottom, which we can pretty much ignore. M squared into the 7 is our answer. Alright, next one here. Oh, I am popular with emails this morning. Keep, change, flip. That's what we do when we get a division. So this here will keep exactly the same, so 48 x to the 5 y squared over 12z 3 times z to the 3 over 16 x squared y squared. Now, because we're multiplying them together, you can almost just think of that this is now one long fraction with a little multiplier on top and a little multiplier on the bottom. So then we can start looking for common factors. So if we're looking for common factors here, I'd be saying, well, 12 goes into 48 4 times. 12 out of there, 4. There's a z to the 3 down here, and there's a z to the 3 up there. There you go. There's 2 x's down here. There's 5 up there, so I'll be left with x to the 3. There's 2 y's and 2 y's. Okay. So then let's see what we've got left. The 4's hanging out there with an x to the 3, and on the bottom we have the 16 still surviving. Alright, and then we can go again. And you can do this as many steps as you want. You don't have to do 3 or 4 cancellations out in a single step. You can do 1 cancellation per step if you want. So clearly here there's a 4 that's going to come out of both, leaving us with x to the 3 over 4. Alright? And that is the end. Alright? Hope you're able to keep up with notes. I'll see you in class tomorrow.